Okay, let's just recap what we discovered last time. We're talking about horizontal and vertical lines. We had an equation last time, y equals a number, and we got a horizontal line from the graph. And we had another equation was x equal to some number when we finished simplifying, at least. And the graph of that was a vertical line. And so those are just general things that happen. The graph of the linear equation y equals some number is a horizontal line, and the graph of the linear equation x equal a is a vertical line. And we can just come in here, just say if we found the place B that we're using, then we'd get the line y equal to b would pass through there to this horizontal line, and we found a place A here on the x-axis, then the vertical line would be the one that passes through the value A on the x-axis. So that happens every time you see an equation that only has an x or a y, and it's supposed to be a graph of a line. There'll be horizontal and vertical lines. So the next thing we have to work with is kind of a challenge question. It looks like this. We're looking at line segments. So we'll just make a line segment. It's just a line segment. It's just the part of the line that connects 2 points. So we'll just find some points here. Here's one. Here's another. So that's 1. Oh, I better label this. 5. I don't want it there. Let's put it over here. 2. Sorry, 4. 2, like that. So x is 4, y is 2. And for the first one, x is 1, y is 5. And then we'll draw the segment connecting them. Okay. And what we're interested in is the coordinates of the midpoint. Of course, that's a line. And this midpoint, it's the same distance from this point as from that point. So you could, I suppose, make similar triangles, maybe like this. And you say, well, this whole length here is to that short length, as any whole length there is to the short length. Okay. And that would say that, for example, this total change in y values, to get to the midpoint, you only have to go half as much. And for the total change in x values, to get in the midpoint, you only have to go half as far. Or another way to say that is that the y value is halfway between the y values. The way you get halfway between two numbers is by taking the average. So we say for the x coordinate is the average of x coordinates. So the x coordinates are 1 and 4. So we do 1 plus 4 over 2 to find the average. That's 5 halves. So this spot here, which is the x coordinate, is 5 halves. And for the y coordinate, same deal. The y coordinate is the average of the y coordinates. So the y's are 2 and 5. So 7 halves. My picture's not the best. This was actually a bit higher up. And this center point is supposed to come here at 7 halves. Well, that seems right, because you're going from 2 to 5, and there's the middle. There we go. Close enough. So generally, we'll write a formula down. If you have 2 points, x1, y1 and x2, y2 are the coordinates of 2 points So we got to say something about this. So we have x there to indicate it's an x-coordinate. The 1 next to it is to indicate it's the x-coordinate of the first point. Down here I've got y with the 1 next to it. The y is to remind you it's a y-coordinate. And the 1 next to it is just the y-coordinate of the first point. And similar stories here for x2 and y2. The x there is to remind you that number is supposed to be an x-coordinate. Even though it's in the first spot, you would already know it. And the 2 says it's for the second point, and y for y and 2 for second point. So if we had those kinds of values, so that's like x1 is 1, and y1 is 5, x2 is 4, and y2 is 2. And then we want the midpoint has coordinates. Well, they're going to be the averages. So I'll write it down like this. x1 plus x2 over 2, and y1 plus y2 over 2, like that. All right, so that's how you find midpoints of line segments. And that pretty much ends section 2.1. And then now we can move on to section 2.2.